Let me give you some scenarios. Imagine you're working on a paper, and you keep on revising parts of your paper but still want to keep the old parts for reference. You may paste it on a new page or just preserve the whole version and just create a new copy of the file. But then you keep on revising and revising. But what if you're working on a large project like a codebase with multiple files? How do you efficiently keep track of all your changes? Or how about you're experimenting on your code and along the way, hindi na siya gumana? How do you go back on the working version? Imagine you're working in a group project, but remotely. Yeah, Google Drive may work for some files, but again, what about a codebase? What if you're building a website? You're working on the navigation, someone else is working on the footer, someone else is working on the content. How do you cohesively merge these edits? There is where Git comes in. Git is an open source distributed version control system. Control system meaning Git stores and keeps track of our files. Version control system meaning Git preserves history. It keeps track of our changes and allows us to conveniently go back on a version if you want to. Distributed version control system meaning through Git, the complete codebase including its full history can be mirrored to every developer's computer, allowing all developers to work on their local copies remotely and independently, but also having the convenience of keeping track updates on every files from other developers. Bottom line, Git keeps history of our files and it allows better collaboration. But before we get our hands dirty with Git, let's first set up Git in our devices. Open your web browser and go to git-sem.com/download. Here you can see different operating systems. I'm using Windows, so I'm going to download the version 2.30.1 for Windows. For Mac users, just follow the instruction on this page. They also have instructions for Linux users. Once the download is complete, open the installer, read the terms and condition. For now, we will just leave the default configuration. Let's now launch the application. We now have Git installed in our devices. Now that you have basic understanding of Git, let's now talk about other components that you'll need along the way. We have the concept of repository. A repository is a storage for our files. Example of a repository is a folder inside your computer where you place your code. This is an example of a local repository. We also have remote repositories, or a folder placed somewhere else, or in a server, that mirrors or reflects your local repository. We have different hosting services for our Git repositories, like GitHub, or Bitbucket, or GitLab. There are other services out there, but for this particular lesson, we will use GitHub. Remember that Git is a distributed version control system, and GitHub is a platform where we can host our files. These two can be used together to improve our development process, but they are not the same. Additionally, you can use Git without GitHub, or use GitHub without installing Git. Now, let's try to set up our GitHub account. Open your browser and go to github.com. If you already have an account, you may skip the sign up. But if it's your first time to use GitHub, open the sign up page and create your account. Once your account is created, try to sign in using your credentials. I'm blurring my account for privacy, but you may explore the site as you go along with the lesson. Now, let's try to have a hands-on experience working with Git. I suggest you follow along and try to replicate what I will do in your devices. Open your console, or in this case, I'm using the Git bash that comes along with the installation of Git. If you're on Windows, you may also use your command prompt or Windows PowerShell. Just make sure that the Git is properly configured, else you have to configure it in the environment variables. If you're on Linux or Mac, make sure that Git is installed in your device. I was able to open this command line interface by searching git bash on my device. There are two common ways on how you can interact through Git. The first is through the command line where we will type all our commands. Alternatively, Git also provides a graphical user interface, but most developers prefer to work through the command line. In this lesson, we will cover the basic commands in Git. First, let's try to locate our directory. I wanted to move to desktop, and I created a new folder named comc100 using the make directory command. Then I moved into comc100. This command initializes this folder as an empty Git repository. And then using the command git status, we can now check the status of this repository. Since this is a newly created repository, we don't have much in our status. It just showed us that this is on branch master, which I will explain later. No commits yet, and nothing to commit because we don't have any files yet. And if we use the command ls to display all the files, -a to display even the hidden files, we will see this hidden folder git. This indicates that this blank folder is now a Git repository. Now let's configure our email and username. We can individually define a user for each of the repository that we have in our computer. This is very helpful, especially if your device is accessible to many people and you want to define which user works on a particular repository. So I just cleared my screen. Now, let's try to ls all the files. So as you may see, wala tayong files as of now. Now, let's try to create a file. So I created a file using the touch command. So I have your touch guiam.txt. This is a blank text file. Now, I wanted to put some text inside of this file. And let's see how Git will keep track of this file. So using the V editor, I wrote hello world. Let's try to print the content of the text file. So it says hello world. If you're not familiar with V editor, you can also use echo. So the echo command will just print this text inside of that file. So if we print again the text file, we now have two lines of text. We have hello world, which I edited using the V editor, and then the hello comc100, which I edited using the echo command. Now let's try to check the status of this repository. Using the git status command, it says here that on branch master, no commits yet. And then we have an untracked file. And then we see here the file name in red text. So we have our guiam.txt, and then we are notified using the git status that this file is untracked. Meaning, this is not yet indexed, or Git doesn't know this file yet. So we have to add it in the index so that Git can keep track of the changes in this file. So let's try to add that. To add the file in the index, we have the command git add -a. -a meaning it will add all the new files or all the changes in this repository. So for now, just ignore if you have warning messages. Now let's have git status again. It says here that changes to be committed. And then we have here guiam.txt, which is our files that we previously added, now in green text. And the status is changed to be committed. So, sir, ano ba yung git add na yan? Basically, you will encounter three major steps in the Git workflow. We have git add, git commit, and git push. Yung git push, I will discuss it later. But now, let's focus on git add and git commit first. So git add, this tells Git to add a new file or changes to Git index for tracking. Also the staging area for files to be committed. And then git commit creates a snapshot of the current stage changes. It creates revision, allows you to jump from one version to another. So siguro pinaka-layman's example is going back to our intro. we're working on a file and then nagtatype tayo ng mga paragraph sentences. And then if we wanted Git to keep track of that file, we git add. Meaning we're telling Git to keep track of all the changes of this file. Now, sa git commit, nagkakreate tayo ng snapshot or parang milestone of the current status of our files. It allows us to jump back from one version to another. So for example, kung ayaw natin yung revision natin, we can just go back dun sa original file kasi na-preserve natin siya. So in our code, wala pa tayong git commit. We just added one file. So let's try to add another text. So we have here text1.txt using again the touch command. And then I created another file, text2.txt. So as of now, we have three files. We have guiam.txt, text1.txt, text2.txt. If we type git status, ang sasabihin niya, changes to be committed, meron tayong na-stage na kanina, yung na-add na natin, which is yung guiam.txt. And then we have two untracked files. These are new files that are not indexed yet by Git. So hindi pa niya to natatrack. So what we can do is, again, we can just git add -a to add all the new files. And then, now, meron na tayong tatlong files added. So, meron na tayong 3 files to commit. So, let's try committing this change. So, we can commit these changes by git commit -m, meaning ng message. And then, we enclose in a quotation yung ating commit title. This title is helpful so that we can reference kung ano ba yung ginagawa ng commit na to. So that it's easier to keep track and to debug kung saan tayo nagkamali because we put title in our git commit. So just make sure to put a title for each commit that makes sense. Basically, you will see here the listing of files committed. So take note that only files added can be committed. So if you type git status, it says here that on branch master, nothing to commit, working tree clean. Because we have already committed all of the changes. So wala na siyang nakitang changes doon sa ating directory. So check lang natin, we have 3 files. And then I will try to edit some files. So let's say we echo hello text1 to text1.txt. And then we echo hello text2 in text2.txt. So introduce changes in these 2 text files. So let's add these changes. So we can use git add -a, but alternatively we can also do git add -a-p. So -p allows us to review first all of our edits. So I personally prefer this one because you can individually see the lines of codes that you edited. So in this way, you can make sure that you are just adding the changes that you intended to add. So since we have 2 edits, we just added 2 edits. Now let's try to view the status. So it says here that on branch master, changes to be committed. So we have added these 2 changes. So these changes are now on staging and are ready to be committed. So let's try to commit these changes. So we use git commit. We use git commit -m and then we enclose in the quotation the description or the title of the commit for faster commit, but I personally prefer git commit. So when you do the git commit without the dash, it will show you an editor something like this. So in this, you can briefly describe the commit. So you can be as descriptive as you want. We wanted the commit to be more descriptive so that other developers will understand what this commit is doing. So conventionally, the first line will be set for the titles, and then we leave 1 space, and then the third line will be for the actual descriptions. So example, let's say the title is edit content of text, and then we just added the particular description of our edit. So we have add line to text1.txt, add line to text2.txt. So that if other developers will read our commits, they will have a comprehensive understanding of what this commit is doing. And then if we type git status, it says here that on branch master, again, nothing to commit. So I just cleared my screen. And then to view all of the commits of this particular branch or directory, we can use git log. So git log will show all of the commit logs of this directory. So we have here on the top of our log is the most recent commit. So we have here edit content of text and then the description I placed earlier, and then the previous commit, which is my first commit. So in this way, you can keep track of all of your changes. Now let's talk about branching. In Git, you can create a branch to encapsulate your edits. If we type git branch, it will print all the available branches of this repository. As of now, we only have one branch, which is the master branch. Master branch is also the default primary branch of Git. If we try to make changes in our codes or files, it will automatically edit the files in this branch. But most of the time, we wanted to preserve the status of the master branch with the latest working commit. So what we do is we create another branch. Basically, it is like copying to another folder all of the current files. So the status of the newly created branch will be based on the current status of the origin branch. So to create a new branch, we use git branch and then the name of the branch. The more descriptive the branch name is, the better. But for now, let's just try putting new branch. Now, if we type git branch, we now have two branches in this repository. Branch new branch will be based on the branch master, but these two branches will have independent copies of the files. Now that we have secured our master branch, we can now play around on the new branch without damaging our codes in the master branch. Currently, we are on the master branch. Let's now move to the new branch. Git checkout and the name of the branch you wanted to use. We are now inside new branch. So let's try making some changes. I will create another text file, text3.txt, and add this to staging. And then after adding, I will commit this file. If we look at the logs, we now have 3 commits on new branch. The 2 commits I created from the master branch, and now on the top of the log, we have new commit, add new file text3. This commit is only local as of now to this branch. If we go back to branch master and check the commit logs, we can only see 2 commits because the edit is not automatically reflected to this branch. Thus, we have isolated our edits in the new branch. If the edit is good and we wanted it to be merged to our working branch, we can merge these edits or commits using the command git merge. And then we will specify the branch name of the branch we wanted to merge with this current branch. We have no error, meaning our files has no conflict and were cleanly merged. If we check our commit logs, we now have 3 commits inside of branch master. So we know that we have successfully merged our commits from the new branch. So now we have 2 branches and 3 commits. Let's now add our remote repository. Again, a remote repository is like a file storage outside of our own devices. Our files and commits can be stored on a code hosting service like GitHub. If we reflect our commits from our local repository, which is the directory in our computer we are working with, to a remote repository, other developers will be able to get those updates from our branches. So we will create a repository in our GitHub account and connect it to our local repository. So to make our remote repository in GitHub, go back to your account and then click the new button to create a new repository. So write your repository name, which also will be the identifier of your repository. You can select whether if you want it to be public or private. Let's just put it in public. And then you will be redirected to a page something like this. Now, on the top, you have your HTTP and SSH, and then you have here a link, which is the link of your repository. So for now, we'll just use HTTP, but I suggest you explore with SSH because that is a lot better than HTTP. So to add our URL, just copy this HTTP URL because if you select SSH without setting up your keys, you will encounter an error. Move back to your git bash and then type the command git remote add origin. This will add a remote origin, which will be the URL that we copied from GitHub. So now we added that URL. Now, to upload all of our changes with the branch and all of the commits, we use the command git push. So this will push all of our changes, all of our files to that origin. So I type here git push origin master because we're on branch master. But you can also push on a specific branch from a different branch, but depending on the case on why you wanted to do that. So I have here git push origin master. So if we encounter no error, you'll be good. Let's check out on our another branch. And to mirror our local repository, we'll push it to another branch as well. So let's push it to new branch. If we go back on our browser, let's refresh the page, and now you can see that our code reflected on our repository. And then you have here two branches. We have the master branch and the new branch reflected as well. So now that our files and all of our histories and edits are now in our remote repository, it is now safely backed up. So if we wanted to go back to our local copy and delete it, or accidentally delete it, or intentionally delete it, we can just obtain a copy from our remote repository. So let's try to delete this folder. So now that we deleted it, how do we obtain a copy from our remote repository? We can clone the repository. In cloning, we can just copy this URL and use our git bash or our terminal or console using the command git clone and the URL. Again, we'll just be using the HTTP. So by cloning, we'll just download all of the files. Or alternatively, you can also download it as a zip file. And then your files are there. By default, yung master branch copy yung mata-download natin. But you can also just check out on different branches. And by the way, the name of the folder where the files will be cloned will be of the same name of your repository in GitHub. So in this case, the name of my repository is sample repository. My previous folder is named CMSC100, if you can remember. But here, if you see the CMSC100, it will not be detected because it was downloaded in sample repository, the same name of the repository in your GitHub. So don't be confused on that. And since I set the repository to public, you can actually access the repository in your browsers. And you can even clone your own copy of that repository. For now, we will end our discussion here. We have covered the basic of Git, and this knowledge are essential for you to get started working with Git. Git is a very wide topic, so I encourage you to explore more or dive in more with other Git commands.